Morning. So you've heard from each of my division presidents, all of whom were handpicked by me. I've actually changed out almost the entire management team at Pratt in the last 15 months or so. And I did that because of what is in front of us, of the challenge in front of us and the opportunity in front of us. So I couldn't be happier to have each of these individuals here with me this morning. I'm going to try to put a bow around what they talked about in each one of their segments. And then we'll engage in a Q&A that Suzanne will MC for us. So if you look at our portfolio, we think we're pretty balanced. About half our revenue in 2016 came from the commercial engine business, and the remaining half was split equally between our Pratt Canada affiliate and our military engine business. And we like that because those businesses tend to cycle differently. You know, usually if we've got a cyclicality in the commercial business, John has businesses, whether it's business aircraft, civil helicopters, whatever it might be, that typically don't cycle that same way. Military, of course, is really tied to the budget and being on the right platforms, so they typically can help insulate us from the cyclicality of the commercial business. And that's why we like the balance. I would argue we have a small engine business that is second to none in the industry. If you look at GE, look at Rolls-Royce, they do not have a small engine portfolio that comes anywhere near what we've got in terms of breadth, scope, and customer position. And if you look at our military business, we would argue that we are better positioned than either of our competitors in terms of the platforms we're on, be it Joint Strike Fighter, tanker, or bomber. And that the two opportunities that Matt talked about in the T900 and the next generation fighter engine, we believe we're well positioned for as well. Now we're humble about that because we have two very good competitors. GE and Rolls-Royce are excellent companies. They've got great technology, good customer relationships, and they are ferocious competitors. So we're grateful that we're different, and we think we can differentiate ourselves relative to either of those. We're mindful of how powerful and capable those companies are. So we've got a balanced portfolio. We believe we're positioned for growth, as was shown in each of the segments that were presented this morning. And at the end of the day, we focus on the core. We're not interested in going out and doing something beyond engines. We're going to focus on our core, and that's where all our investment's going to be. It's going to be in engines, it's going to be in the infrastructure, and it's going to be in the digitalization of all of that. So these charts you saw earlier, this is the chart that Chris showed in his presentation about what the GTF means to us in terms of growth in the commercial segment. The Pratt Canada business, as John said, it pretty much grows at 5% per year, and that's pretty much the historic norm, and we believe that continues to go. And then the military engines, because of how we're positioned, our base will grow there as well. Now, if I add up all the engines we have in service today, APUs, propulsion engines across the three businesses, we have 89,000 engines in service. And that 89,000 engines in service is what helps to feed our aftermarket. So to Chris's point, that aftermarket's key to us as we get through this heavy investment period of GTF and start to feel that product in quantity such that it begins to hit its overhaul cycle. So again, that 89,000 engines we view as a strategic advantage. This morning, I hope you get something out of the demonstrations in terms of what we're doing in digital. And I thought it was really important for you to see and touch what we're doing. Because I read a lot about what people are doing in digital, and everyone seems to have the same strategy in terms of capturing data or using algorithms to help do better on predictive maintenance. But my view of it is that until you can connect the entire value chain end to end digitally, you really haven't captured the benefits that digital can bring. So whether we're looking from a strategic perspective, whether we're looking from an employee perspective, whether we're looking from a product perspective, whether we're looking from an aftermarket perspective, my view is until we can connect that value chain, we probably won't realize the full benefit of digital. Now, what you saw this morning were some of our more strategic initiatives in regard to that. These are basically points of light, if you will. But until we can literally connect them end to end, I don't think you realize the full benefit. So we're out doing that, and we probably, to be honest with you, I think that's gonna take us 7 to 10 years to get that completely done. When you look at what you've gotta do for connected factory, what you've gotta look at, what you've gotta do for just developing the algorithms in terms of what these engines, how they perform, particularly the newer generation engines, it's gonna take a while before you can connect that end to end. But that's what we're about, and that's where we're headed, and that's where some of our investment's going. You know, engine-wise, we talked about the digitalization of the factory. This automated manufacturing cell that John talked about up in Longueuil, I mean, it's phenomenal what this can do. It does turbine discs, one of the most complicated parts we make. Obviously, a safety focused part, obviously. Can't burst, can't fracture, life limited. We basically have taken lead time from 4 weeks to 2 weeks. We basically eliminated any scrap on the line that we used to see, so the quality is virtually perfect. And we do it with 80% fewer people than we used to do it with. So we really have now one individual that's responsible for that entire cell for turbine disc manufacturing. And his or her role has changed significantly. We've actually had to train this individual over 400 hours. 400 hours for them to worry about troubleshooting the robots, doing the preventive maintenance, balancing the line to make sure that that it's synchronous, because the robot moves the part from station to station with no human intervention. To make sure that from a statistical control perspective, we're actually machining to the dimension as intended by the print. So that if he starts to see that actually vary slightly from what we would like in terms of the mid-range, he has the ability to go in and actually reprogram and allow that machine to continue to machine within its dimensional tolerance as permitted by the blueprint. These are all things that that operator wouldn't have done historically. Historically, they would have loaded the part on the machine, they would have hit the button and let the machine do its thing, really blind to whether or not statistically that disc was going to be perfect until it came out of the machine and we measured the dimension. Now we do it all real time. Now that capital investment in that one cell is about $50 million. So it's not inexpensive to do this. And I don't think we will automate every step of what we do in a jet engine. But for things that are high volume, safety critical, where dimensional tolerances are incredibly important to us, and where we've had issues with scrap, I think you'll see us go the automated route. There's some things we will never automate. Highly unlikely we're going to automate assembly of a jet engine. Highly unlikely. They're all unique, externals, plumbing. It's probably, you could never justify the capital investment to actually make that happen. Unlike a car where they have, millions of them that are running off the line, they can justify that capital investment. So it will be selective, but we will do it in those areas where we think we get a payback. And then how you tie the factory together digitally so that you probably saw the connected factory demo this morning. How we tie that whole factory together digitally so we know where the supply chain is in terms of giving us the raw, we know where that part is on every machine, where it is in the process, what its dimensional tolerances are, so that every morning I can come in and hit a button and know exactly what I produced last night and what the yield was. That's where we're headed. So we're gonna do that in our hot section module center this year. We're actually gonna take the high pressure turbine main line and we're gonna make that a connected factory where we have total visibility from end to end of what happens to that part. After we do that pilot, there'll obviously be some lessons learned. We'll take the lessons learned from that pilot and then we will extend it across the rest of our factories. Finally, the command center. No, was there a demo about that, Julianne, this morning? So what's the command center? The command center is actually, we have a command center at Pratt, Canada, and we have a command center down in Hartford. What that command center does is it's able basically to tell us by engine where the part promises are for every engine so that we know the parts are gonna be there when we wanna pull that material out of our New England Logistics Center and build the engine. Heretofore, we would get a supplier promise, and it would be a promise. We couldn't validate it, we couldn't verify it, and lo and behold, a lot of days, suppliers would call you 2 days before the part was due and say, by the way, I'm gonna miss that delivery. You can't live that way in a high volume environment. So now what we've done is we actually have people, we've added about 300 people to supply chain that go out to suppliers and validate and verify the WIPs and positions. So they started on time, their WIP over lead time is where we need it to be, and their yields are where it needs to be, so that we have a better indication that they're gonna hit their promise date. We do that for every part in the engine. So if you were to come to Hartford and go into the command center and say, okay, I wanna see what your GTF build is in the next 6 months, we could show you by engine serial number what parts were there, what parts were on schedule to support the build, and any parts that may have been off their commitment. Then we know exactly what supplier to go work with, so we do it before it becomes a crisis. The power of this has been instrumental in us being able to ramp up the GTF and actually be able to support our existing fleets. We still build 400 or 500 V2500s a year, so obviously we use it there as well. But this power of data real time that lets us go work on the problem hotspots before they become a crisis has been really key to us on the ramp. And we're gonna continue to innovate. Innovation is the price of admission to be in this industry. And we believe that we've always been the innovators. We're the only engine company with a geared turbofan. We're the only company with a 5th generation fighter engine. And we're the only company with a business jet engine, namely the PW800, that's 10% better than anything else flying. We really do believe that we innovate above and beyond all else, but it never stops. So some of the examples I'll show here is this hybrid aluminum fan blade. You know, long story about that. Last year it obviously caused some delivery issues, but that fan blade allows us to have the highest efficiency fan blade in the world. And the reason is aluminum lets you make the cross section of that blade very thin. And the thinner it is, the less the aerodynamic loss. That fan blade is north of 98% efficient. It is one of the best fan blades in the world. Then we look at high pressure compressor technologies. We're looking to see what we can do to basically get rid of any residual loss and optimize aerodynamics. And why do we want to do that? Because we know the next generation of engines is going to require a higher overall pressure ratio. That higher overall pressure ratio drives the temperature in the rear of the compressor. And so the more efficient you can make that compressor, the lower the temperature will be. But the world is going to drive us to higher overall pressure ratio and higher temperatures. So having compressor technology that can give you efficiencies that are 2 or 3 points better than maybe we've seen historically is key. High temperature materials. We've always fancied ourselves to be the leader in high temperature materials, whether it's in our discs or whether it's in our turbine airfoils. Today we use double wall turbine airfoil technology and cooling and coatings. We think in the next generation of engines, we're gonna have to use ceramic matrix composites. We think that ends up in a product in the next 5 to 10 years. We're off developing that capability today, and it'll be ready for when we do the next product introduction. And then finally, advanced manufacturing, additive, a lot of conversation about additive. So I'm gonna give you my opinion about additive manufacturing. I think today, how the technology exists, you can only lay metal so fast. And in fact, for high production, we would argue that maybe the technology is not quite ready for high production. We do one part in the GTF, we do it as a bracket for our HPC sink ring that we use additive on because it's a very complex shape and we're able to have enough additive machines where we can produce it. But we think additive technology from a volume, high rate production perspective is still quite a ways away. So where do we use additive? Well, we use additive, we do it when we want to do development program and we need tooling. Usually you go to the conventional tool makers, you know, you're talking about an 8 to 12 month lead time. You can do it in additive, you can probably do it in a month and a half. So it allows you to get that development tooling a lot faster and take some of that length of time away from your development program. So we see strategic opportunity for additive, but we think the ability of lasers to lay metal has to be a lot quicker, like we think 10 or 12 times quicker than it is today, for us to say we can put it in rate production. Now I've read articles about competitors using additive for fuel nozzles or fuel tips. I don't know if it's 100%, I don't know how many additive machines they've got, but from where we sit, we don't think the technology is quite there, but it will be. So we will be ready to take advantage of it. Complex geometry parts that you want in one piece, you can avoid welds, probably not a bad place to use it. But again, when you're at rate production with high volumes, where you're making hundreds of thousands of parts a year, we actually don't think the technology is quite there. Isothermal forgings, we do 45% of the world's isothermal forgings down in our Georgia facility. And that isothermal forging capacity, we basically make all our discs and hubs, shafts down there. And we do it with metallurgy that we think is second to none in the world. So we view that as a pretty strategic lever for us, particularly in engines like the F-135 and the like. So if you remember nothing else from today, I guess I want you to remember this chart. Everybody only wants to talk about GTF. And GTF is absolutely important to us in terms of growth. But we are a much bigger story than GTF. We have a small engine, we have a military engine portfolio that we believe is best in class. And we're humble about that, but we believe it's best in class. No other company, we actually have swept the last 3 big procurements: Joint Strike Fighter, Tanker, and Bomber. You know, when I was at Pratt in my prior life, before I went on to Hamilton and Sikorsky, I can remember sitting in the conference room at Pratt, and we were actually wondering whether or not we were going to stay in the military engine business. GE had F-14s, they had really taken the F-100 market away from us, so the 110. They found their way onto the F-15, remarkably, and we had F-22. But F-22 was not a big production run. They weren't going to buy a lot of F-22s. And we actually sat there wondering what was going to happen to our military engine business. So in that period of time, late 90s, early 2000, we actually thought there was no way for us to come back in the military engine business. And then we won Joint Strike Fighter and the world changed. So the lesson for me out of that was that the world does change. And that if you're in a business and you're invested in it and your legacy is in it, don't ever give up on it, because you never know what's going to happen. So today, we would argue the world's best military engine portfolio. We also argue the most diversified, largest small engine portfolio in the industry. GE certainly doesn't have a small engine portfolio that looks like that. Rolls certainly doesn't have a small engine portfolio that looks like that. And as John said, 60,000 engines flying. 60,000 over 89,000 engines, small engines. So it provides us with a great aftermarket opportunity and a springboard for future opportunity. The thing John didn't say was that Pratt Canada actually does a fabulous job on customer service. The relationships with the customers at Pratt Canada are really good. They're well earned, we work really hard at them, but great products, great people translate to customer loyalty, and I think Pratt Canada is living proof of that. And then finally, and I don't think there's any debate about this, if you go to any of our customers, any of our airframe customers, they will tell you the geared architecture is the architecture of choice. That the gear has more ability to deliver superior fuel burn and noise benefit than other engine architectures. Even though we may have had a few stumbles in terms of, some technical issues that Chris talked about, the combustor and the carbon seal, they will tell you point blank, the gear is the architecture of choice. So that gives us great hope, not only for the 8,000 engines in the backlog, but future opportunities as they may present themselves. So we're a lot bigger story than GTF. We really are. But that seems to be all that people want to talk about. And I get it, big investment, big bet, revolutionary technology. But on the other side of it, we have just as much revolutionary technology in our small engine and our military engine business. And I would argue a strategic competitive advantage for us. The tagline on the bottom of this chart, go beyond, that's going to be something that we're now going to start using across the Pratt Whitney portfolio in terms of our branding. And go beyond means a lot to us. We thought really hard about this. It means go beyond for your customers, obviously. It means go beyond for your shareholders, but more importantly for us, it means go beyond for each other. The culture of a company typically determines how successful a company is going to be or not be. And we are really laser focused on developing a culture at Pratt where people are empowered, people are entrusted, people are allowed to make mistakes and learn from those mistakes. And I'll tell you, I really start to think it's taking hold. And the reason I say that is our attrition rate, when I came back to Pratt in January of 16, the attrition rate at Pratt was running almost 5%. People just leaving, voluntary attrition. And today it's down to 2%. Now, some of that is because of what we're driving on culture. Some of that is because we've added 6,000 people in the last 15 months. But culture, to me, is what makes companies great. And so we are really laser focused on that. So you'll see Go Beyond in Paris. That's where Suzanne and the communications team is going to launch it. But it's got a very deep meaning for us, and more importantly, what it means to each one of us that work in our company every single day. We take our responsibility pretty seriously. You know, I tell my employees every day we hold people's lives in the palm of our hand. Whether that's somebody that's going to reconnect with their family, whether that's somebody that we're going to medevac to safety, whether that's the warfighter defending freedom for our country, we hold people's lives in the palm of our hand every second of every day. Those 89,000 engines, they're in the air every single second of every single day, of every single week, of every single year. And so that's what we think about. Making money is important. We're a public company. We get that. Supporting our customers, really important. We get that. But ensuring safety and warfighters coming home safely and families reuniting and economies moving, that's what we do. And we really believe that's our higher calling. I don't think you hear executives talk a lot about that, but it's true. It's our higher calling. It's what gets the people of Pratt and Whitney to do for us what they do every day of the week. Because we ask them to do some pretty incredible things. And I will tell you that they do it willingly. They do it with a smile on their face. And I really do think we're on the precipice of having one of the best corporate cultures in America. I really do. So with that, I think Suzanne, Q&A.
Absolutely.
Great.
Thank you, Bob.
Thanks.